Good day, everyone. I'm Sir RG Layson, your math tutor and guide on this exciting journey through the world of numbers. In this video, we will discuss all about factoring difference of two square. Now, the product of sum and difference of two terms, it states that the product of a plus b and a minus b is equal to the difference of two square, which is a squared minus b squared. So we have here a plus b times a minus b. We will come up with the product of a squared minus b squared. Now, usually, we do FOIL method in finding the simplest form for this one, but when we have the same first term in each terms and the same second terms in each terms also, but different signs, we have positive, the sum and difference, we can easily find the simplest term for the difference of two square, where we have a squared minus b squared. Thus, in finding the factor of difference of two square, you just have to reverse the given pattern. So the given will be in a form a squared minus b squared, and our factored form must be a plus b times a minus b. Let's recall first the concept of perfect squares. We have 16. What is the perfect square for 16? We have 4. Now we will change this one into exponential form. Since we have 4 times 4 equals to 16, we can change this one into our exponential form. We have 4 squared. We have x squared. We have x times x. So we will change this one into exponential form. We have x squared. For 25a squared, we can the perfect square for this one is 5a times 5a. So we can change this one into exponential form. We have 5a raised to 2. 9y raised to 4. We have 3y squared times 3y squared. We have 3y squared raised to 2. And for 1/4, we have 1/2 times 1/2. So we have 1/2 squared. Now, these are the steps in factoring the difference of two squares. Step number 1, express the first and second terms in exponential form with the power of 2. Step number 2, subtract the two terms in exponential form following the pattern a squared minus b squared. And step number 3, factor completely following the pattern a squared minus b squared equals a plus b times a minus b. Example number 1, we have x squared minus 9. We need to factor this one. So step number 1, express the first and second terms in the exponential form with the power of 2. So we have for x squared, so we have x times x, so we have x raised to 2. 9, we have 3 times 3, we have 3 raised to 2. Then we need to subtract the two terms in the exponential form following the pattern a squared minus b squared. So we have now x raised to 2 minus 3 raised to 2. And in step number 3, factor completely the following term. Since our x is our first term and 3 is our last term, so we can follow a plus b times a minus b into x plus 3 times x minus 3. So that means, hence, the complete factored form is x squared minus 9 equals to x raised to 2 minus 3 raised to 2 equals to x plus 3 times x minus 3. Example number 2, we have 16a raised to 6 minus 25b raised to 2 in completely factored form. We need to write this one. So express the first and second terms in the exponential form with the power of 2. So we have here 16a raised to 6. So we have 4a raised to 3 times 4a raised to 3. So we have here 4a raised to 3 raised to 2. Okay, let's recall the power to a power rule. No, when we have an exponent raised to another exponent, we just need to multiply. So since we have a raised to 3 raised to 2, so it will result to a raised to 6. Thus, the factor form for this one, or the exponential form for this one, for 16a raised to 6 is 4a raised to 3 raised to 2. For 25b squared, so we have 5b times 5b, so we have 5b raised to 2. Next, we need to subtract the two terms in the exponential form following the pattern a squared minus b squared. So we have 4a raised to 3 raised to 2 minus 5b raised to 2. Step number 3, factor completely following the pattern a plus b times a minus b. So we have 4a cubed plus 5b times 4a cubed minus 5b. Thus, the complete factored form for this one is 16a raised to 6 minus 25b raised to 2. 4a equals to 4a raised to 3 raised to 2 minus 5b squared equals to 4a cubed plus 5b times 4a cubed minus 5b. Example number 3. Write a squared b raised to 4 minus 81 in completely factored form. So step number 1, express the first and second term in the exponential form with the power of 2. So we have here for a squared, we have a, and b squared. For we have b raised to 4, we have b squared. So we have now a, b squared raised to 2. Okay, recall the loss of exponent power to a power rule. Any variable raised to exponent and raised to another exponent, we just need to multiply. So we have a raised to 2, we have a raised to 2. B squared raised to 2 is b raised to 4. And for 81, we have 9 squared. Step number 2, subtract the two terms in exponential form following the pattern a squared minus b squared. So we have here a b squared raised to 2 minus 9 raised to 2. Factor completely following the pattern. So we have, let's follow this one, a plus b times a minus b. Since our first term is ab raised to 2 and our last term is 9, so we have here ab squared plus 9 times ab squared minus 9. Hence, the complete factored form is in a squared b raised to 4 minus 81 equals to ab squared raised to 2 minus 9 squared. We have ab squared plus 9 times ab squared minus 9. Example number 4. We need to write x raised to 4 minus 81 in completely factored form. So express the first term and the second terms in the exponential form with the power of 2. So for x raised to 4, we have x squared raised to 2. For 81, we have 9 squared. Next, step number 2, subtract the two terms in the exponential form following a squared minus b squared. So we have our first term here is x squared and our last term or our second term is 9. So we have x squared raised to 2 minus 9 raised to 2. Factor completely following the pattern. We have a plus b times a minus b. So we have x squared plus 9 times x squared minus 9. Hence, the complete factored form is x raised to 4 minus 81 equals to x squared raised to 2 minus 9 raised to 2 equals to x squared plus 9 times x squared minus 9. Notice, class, that the second factor, x squared minus 9, is in difference of two squares also, because x squared and 9 is a perfect square. Thus, it can also be factored out. That is x squared minus 9 equals to x raised to 2 minus 3 raised to 2. We have x plus 3 times x minus 3. So this means the complete factored form for x raised to 4 minus 81 is x squared plus 9 times x squared plus 3 times x squared minus 3. In the example, x squared plus 9 is called the sum of two squares. It cannot be factored. Since x squared plus 9 is the sum of two squares, thus x raised to 4 minus 81 cannot be factored out, class. You need to remember this one. So last example, we need to write 3w squared minus 48 in completely factored form. At the first glance, it seems like the binomial is not factorable because 3w squared is not a perfect square and 48 also is not a perfect square. Using the sum and difference of two terms since the terms are not perfect square, right? Note, however, the first and second terms of the binomial have a common factor of 3. Hence, the binomial can be factored using combination of GCMF or the greatest common monomial factor and the sum of difference of two squares. Find the GCMF of the terms right in the factored form. For their GCMF for 3w squared and 48, we have 3. And the other factor now is w squared minus 16. Now, w squared and 16 are now perfect square. So, we have now w raised to 2 minus 4 raised to 2, or our factored form will be w plus 4 times w minus 4. Thus, the complete factored form for 3w squared minus 48 is 3 times w plus 4 times w minus 4. Now, if you are my student, I want you to answer this one in your notebook. Activity number 1, tell me. You need to identify of the given, whether or not the given binomial is a difference of two square. Write D if it is, and if not, you write N. Activity number 2, missing U, find the missing terms of the factors. Write the answer on your answer sheet or in your notebook. So all you need to do is you need to find the factored form in the given binomial terms. And activity number 3, the last one, whole to parts. All you need to do, class, is you just need to identify the factors for the binomial, the sum and difference of two squares of the given binomial terms. Again, thank you so much for watching. I hope that you've learned something about this lesson. Please don't forget to like and subscribe and share it with your grade 8 friends or your students. That's all for today. Goodbye, everyone, and God bless.